It's not just indoor air quality. We are changing environments. We are changing the dynamics of a home by everything that we do, cause and effect.
Welcome to the Flow Lab, the podcast where we dive deep into the science of building performance and HVAC innovations. Today we bring you another insightful episode aimed to enhance your knowledge and expertise in the field. Joining us are your co-hosts, Ben Walker, co-CEO of RetroTech, and Sam Myers, a renowned building science specialist and RetroTech trainer. Together, they bring a wealth of experience and knowledge to ensure our discussions are both informative and engaging. So, sit back, relax, and get ready to enter the Flow Lab, where we'll explore the world of building performance. Let's get started.
Yeah, we're good to have you on here, though. Good to see you.
My pleasure.
How have you been?
Yeah,
Fantastic. Enjoying a little time at home for a change.
Oh, nice.
I know you're on the road quite a bit.
Yeah, I travel a lot. And so we're getting ready for winter. So I've been, chopping firewood and splitting it and loading the wood shed. And we've been doing deck repair and driveway maintenance and that fun stuff that comes with living in the mountains.
Oh, yeah.
Cool.
What does that wood stove smoke do to the indoor air quality at your place?
Well, we got a new one. So we got a better one. The first one we had was side load, didn't seal very good. And so we got a front load one with a really good gasket on it. And It's been much better. But it is what it is.
Yeah.
And, yeah.
So are you able to draw in makeup air from the outside when that's running?
No, I keep a window open.
Just crack a window.
Yeah,
So that's what we do. We have a wood burning fireplace too that we use when it does get cold enough here, and that's exactly what we do too.
Well, it's a different way of life, and when we bought this, we're the second owners of this cabin, and we did a lot of remodeling and just getting a different wood burning stove, and I did all the flue and cleaned it really well, and starting the fire slower helps because we want to get that chimney warm so it starts drafting. That makes a big difference too. So I start slow and then build up, and that was a lesson learned.
Yeah, awesome.
Yeah, it was soon after we bought this house, I was kind of nerding out with it, and we got a fire going pretty hot, and we didn't have a window cracked, but it was a pretty leaky envelope then. And there was a few nooks and crannies that I knew were leaky. So I probed into with a manometer and just watched that air just come on in. So we would get the fireplace going and then the bedrooms would get colder. So cracking the window close to the fireplace helps.
Yeah, do you monitor the IAQ in your own cabin there and stuff too? Like to monitor along the way, or? Yeah,
I've taken some measurements. It is what it is. Like I said, unless we start tearing this place apart, they did a really good job on the insulation. It's not the tightest, but it's not bad. And it just is what it is. And I've taken some measurements, and my wife and I, we keep an air purifier because we had some wildfires here. And so we keep the bedroom pretty darn good, and we add some humidity when we can because it's pretty dry in the winter.
Yeah, I remember when was that this year or last year? I remember seeing your post about it. It got pretty close, didn't it?
So it burned up to my front porch, and we had a strike team come in, and they did some. I keep defensible space because I was on the fire department here. I just retired, so we had defensible space, and they put a drop tank, which is a big they call it a pumpkin, and then they have a power, gas powered pump, and put some sprinklers up, and then they back burned my back mountain. So I lost my back mountain. It burned upward to my front porch. The front of the property did pretty well, stayed on the ground. We didn't crown, so that's a good thing. But that was 3.5 years ago.
Oh wow! Okay.
Yeah. And so all the ground cover is starting to come back. We've had a great monsoonal flow with lots of sunshine. All the biodiversity of all the ground coming back is just amazing. Lots of flowers and So it's a give and take. We were full forest and you couldn't see the top of my mountain, and now you can. But now because the sunshine gets through and all the pine needles are gone, I'll just start coming in.
New life, yeah. Yeah. Amazing how that works, the cycle, yeah.
Yeah.
Yeah. I know wildfires have been kind of a hot topic in the indoor air quality community as far as like when to pull in ventilation, when not, having some controls that can kind of keep monitoring what's going on outside so that you're not, pulling in air with an ERV or something like that to actually make it worse. So I know that's something that Kevin Hart was talking about quite a bit from Haven.
Yeah.
Yeah, just recently.
It makes sense.
I did an episode on the Grapevine too, talking a little more in depth about what happens with the byproducts, the type of fuel. Pine has a high sugar content, and so it crystallizes faster, it burns different ground cover burn different, but the emissions from it with creosote and the acids, and depending on what the fuel is and how hot it burns, and as it crystallizes, it aerosolizes, and arsenic. I mean, there's all kinds of things that come off of that, including the ash and PM 2.5.
Sure,
but there's a lot to it, and having been in fire suppression for a long time and having taken, wildland fire science and all that fun stuff, and even, and we talked about fighting a chimney fire, how you pressurize a house. We've got a gas fired big ass fan, and we put it in the front door. You fire it up, you close all the door, you fight that chimney fire from the inside because you want to force that mist up, because if you do it from the other side, you're going to get blasted from it because it's already chimneying. And so I'm like, dude, that's building science right there.
Yeah, we talk about that stuff all the time, just for different reasons.
Yeah.
Oh, that's cool. So, tell us a little bit. I know a big project you've been working on here lately is the dust-free 16 filter. And that's one I know there's been a couple of projects here in Wilmington that I've worked on where there's been some sensitive clients that have been looking for better filter options. And so the contractor that was working on it, I've definitely recommended it. Some of the photos and just the readings that you've sent me off of it are pretty incredible. Tell us a little bit more about that.
Yeah, so I want to start off by saying V-Bank filtration is nothing new. It's been around for a while. And there are some other manufacturers that use that principle. And I want to also say that we didn't invent the mousetrap. We just built the best one. And so that being said, I took this to Dust Free before they were acquired by Rector Seal. So I took it to Dust Free, and I've had dialogue with them for some time. And I sat down with the owner, Greg, and the engineers. I said, look, we need to take this to market because our competitor's business model is terrible. And I won't say names, but it's just terrible. And I've been teaching IAQ and promoting IAQ for a very long time, and filtration being a big part of that. And I got calls like, John, what's going on? What's going on? It's like, so I had a very tall order. One was the performance, right? And ultra low static, being user friendly, and being able to get this to market. And so we went in, we did a little bit of reverse engineering, if you will. And I had just a blast. I worked 2 years with the engineers, and I love engineers. I always say, yesterday I couldn't spell engineer, and today I are one.
I'll have to use that for myself. Yeah.
Fantastic, right? But what they don't have is field experience. So I brought the field into the lab, and I said, look, this is what we need to do. And after a whole slew of running computational fluid dynamics on different scenarios and trying to, track what we're able to do, and then, all the way to procuring raw materials for the filter media, which we didn't get in the United States. We got it from Europe. We pleat here in Texas. And so understanding what it was I wanted to accomplish, ultra low static resistance, being able to fully get our ASHRAE 52.2 credentials for a MERV 16. And that was, Greg says, if we're going big. So most filter manufacturers get their filters credentials for 52.2, but very rarely do they do the housing and the filter. So we have credentials for both, the filters themselves and the whole system and the housing. So that was important. And then I geeked out. Yeah, how we buy our children presents and they play with the box.
Yep.
The engineer came to me and said, John, look, we're able to do this knockdown. And he brought it to me, and it comes in 2 boxes. One is the filter housing that you can assemble in about 10 minutes. And then the other box has the filters in it. So you can go into a space, you can go under a house and assemble it. You can take it into an attic, assemble it. You can assemble it right there on the floor in the living room if you need to. And so that was huge, because when you, and this is a part that I really didn't have a whole lot of knowledge in, and that was manufacturing and 2-point distribution. You're paying for shelf space. And also shipping. And so if you have this giant filter in a box assembled, you're paying to ship air. And some of it is weight too, but some of it is a physical size. And so that was like super duper important. We're able to ASHRAE 62.2 MERS 16. We're about a click and a half below HEPA. We're getting 98% filtration. We're getting at PM, we're doing a lot of work in PM 2.5, but 0.3 microns, we're just killing it. And we're getting 3 years out of a filter life, which is huge. Wow. And we're using all 5 filtration methods, which would be impingement, diffusion, interception, electrostatic, and I'm going to forget the last one, but when you're looking at filter media itself, those are the 5 prominent methods. Our filters are 2.5 inches thick. We have a very robust electrostatic attraction. And for our viewers that don't know what that is, when you take a balloon and rub it on your arm and it sticks to the wall, that's electrostatic attraction, not electronic. But that has to do with the filter media, what it's made out of, both organic and synthetic, nanofiber technology, how it's woven. And as the air passes, it creates that static electricity. So our front loading is phenomenal, but our secondary loading is also phenomenal because we carry that electrostatic attraction through the media. And so that's why we're able to hold our MERS 16 for the life of the filter. Respectively and subjectively, we're getting 3 years out of a filter change. In the right environment, we could get 4, and we'll never lose our MERS 16. And at the end of that filter curve, we'll start to take a static hit on our static resistance, but we end our filter life at the end of 3 years, where most filters start brand new.
Oh, wow.
Wow. I didn't realize it was 3 years. That's pretty incredible.
Yeah.
Well, it's all about surface area. So we have 2 models. One goes up to 3 ton, and it's in an N V-bank configuration. So there's 3 filters. And then the 5 ton, or the 4 and 5 ton, we've got 4 filters in a W. Each filter has 70 square feet of surface area in it. Yeah. And then also with that nanofiber technology and the way it's woven in the material that we have chosen, that was a big deal.
Yeah, that's awesome.
Wow. Yeah, that's really cool.
So that's what reduces all the static pressure, right? Is just that you have a lot more surface area of filter through there. So like it doesn't take so much effort to draw the air through.
Exactly. It's all about surface area. So the 4 and 5 ton at 2,000 CFM, 492 feet per minute, we're coming in at a 0.18. That's published data, which is conservative. I got guys in the field that are bringing them in live systems at a 0.16 static drop on 2,000 CFM. Wow. And our other one that does up to 3 tons does 1,200 CFM at 492 feet per minute. We're bringing it at a 0.13. And that's published data. And I got guys in the field that are bringing them in less than that. So it's phenomenal.
Nice.
Phenomenal performance.
Yeah.
Yeah, that's awesome.
And then you're able to buy them through like TrueTech Tools and other places, or?
Yeah, we again learning about 2-point distribution and what that entails, and now we are since we've developed that filter, Dust Free was acquired by Rector Seal. And so that's our channels now. And we do have some suppliers that are carrying them. It's hard to get them to see the vision. But Bill Spohn was really great. He saw the value, and I approached him. I said, look, we're ready to go to market. Would you guys like to be the first? And so they were. And honestly, they're having trouble keeping them in stock. They're selling out like every couple of weeks.
Now that the word's out,
they had to change their, so, when you're doing distribution, you have to have a flag that says, hey, our inventory is here, we better order. They had to change that because they weren't coming in quick enough. And next thing you know, they had 0 in stock and they're waiting on the new shipment. So I think they got a good flow going on. And I go on their website and check periodically. That's
see how sales are going like that.
Yeah. And then, awesome. I get mailbox money. So that's always a good thing. So.
Oh yeah, exactly.
So now I'm working on my next product development with them. We've gotten all our concepts, rough drafts, design parameters. We've done a little bit of raw material procurement. We've done some market analysis, and they have it. They're running it up the flagpole, and we're going to see. I'm hoping there's going to go through. It takes a little while before Greg's like, let's do it. And now we got to run it up the corporate flag.
I think we know a little something about that.
Yeah.
Good products take a while to come to fruition, but
they do.
It's worth the effort.
So what got your initial interest into indoor air quality and why it mattered and things like that?
And that's a great question. And so 43 years in the industry, I'm HVAC strong. 20 years doing building science. I was an early adapter. I had a business in California. It was SoCal Aerodynamics. It did not say heating and air conditioning. It said performance contracting. So I was an early adapter of that whole house as a system. I got to work with some great building sciences, Scott Johnson, Rick Chitwood out of California, took me under their wing and said, hey, let's go fix houses. And it was like
awesome.
Bill Nye the Science Guy, man. We did everything imaginable. And I will say, just because you can doesn't mean you should. But we tested everything, every which way, you could possibly look at things. And so that sparked my interest. And then I connected with a gentleman named Gene Sperling. He was a respiratory pharmacist, got his degree in pharmacology from University of Oklahoma. And he got tired of seeing what Big Pharma does and throwing pharmaceuticals at people. He sold his brick and mortar, got out of that, and started doing pharmacy audits just to see how people were handling and running their businesses. And then eventually approached myself and said, John, I really want to get into the environmental. I want to get in people's houses. I've got relationships and I want to learn building science. And so he took that journey and then he's like, let's go fix some houses. And through him, we had a relationship with LA Children's Hospital, UCLA Medical Center, USC Medical Center, several prominent immunologists, oncologists, and allergists and respiratory folks in and around the greater Los Angeles and Beverly Hills area. And it got to the point where doctors were literally prescribing our services to their clients. We've got some wonderful studies where people are going off medications, increased lung functions. So our clients would come to us with cystic fibrosis, COPD, immune oncology, lung transplant recipients, Lyme's disease, valley fever, debilitating asthma, all the way down to your garden variety seasonal allergies. And so when clients are having acute compromise like that, the very decisions we would help them make, not only did their quality of life, but their very life could depend on those decisions. So this wasn't about throwing a magic gizmo in their system and hoping for the best. It was based on real building science, building forensics, and a lot of medical involved too, because Gene talked doctor talk. And so he would oftentimes have a meeting with the doctors. But that was really the launch of how we do what we do at the level we do it, and coming up with a process and a system to do that.
Yeah. You weren't talking
that's
about
so refreshing to hear. I mean, I really wish there was a better connection between what we do and the medical industry.
I'm working on it.
If we're trying to fix, if your house is making you sick, source control is what you have to get down to the bottom of, and just throwing medications at it is just kind of putting a Band-Aid on it instead of really getting to the root cause, which is where we come in.
Well, and thank you for saying that. I've got 6 key principles that I just drive home, and they're foundational that I teach in my class. And then we should be doing these in our everyday HVAC businesses. already, and that would be thermal comfort. We are in the comfort business, are we not? We sell comfort, and comfort looks different for different people. But for people who are compromised, both immunal and respiratory compromised, thermal comfort is huge, and how they feel. Right. And I've got clients that can walk into a building and feel the pressure in a building. They can feel it. Their body feel it. Our bodies are the best testing instruments. And so from thermal comfort, we go to a ventilation. Let's put the V back in HVAC. I always teach in my class, the why never changes, just the how. How I would do ventilation in California, Washington, Nevada, Arizona, Utah, right? It looks a lot different than how I would do it in Houston, Louisiana, Florida, Alabama, Georgia, et cetera, right? So the how never changes. The why never changes, just the how. So we need to do ventilation. Even if we're looking at just dilution is a solution for certain pollutions, but it also is a good, just general healthy home. And then we look at, in commercial, we do ventilation for building pressures all the time. Right. So, that's a tall order, but it can be done. And oftentimes we'll take an energy penalty for a good ventilation strategy if we're trying to at least go neutral pressure. In a tight home, we might be able to get positive, or I can get 5-10 pascals. That's great. We'll take an energy penalty. But if I got a client that's now not spending $70,000 a year on medical expenses, that's really worth it. So we got thermal comfort, ventilation. We got to talk about filtration. Every piece of equipment we walk up to has some type of filter in it. And so if we look at good filtration, how it's designed into the system, no bypass, right? Good solid filtration. One, we'll keep the equipment clean, but we'll clean the environment as well. Then we go to humidity control. Too much or the lack thereof, depending on where you're at, right, is going to be different. And so like up north in Indiana, Michigan, Minnesota, don't you know, and upstate New York,
that's where I'm from, actually.
Right? Well, they do humidity, a humidifier in the winter. They do a dehumidifier in the summer, and they've got like ERB for ventilation. It's a good, solid approach for just general building practices, but good IQ as well. And so then we move into the building science, and we look at building pressures, and we look at infiltration. When I do my diagnostics, I go in and I baseline the house. I do pressure mapping. I do moisture mapping. I do temperature mapping, not just stacking, but I look at stratification and what that looks like when I introduce heating and air conditioning, identifying a neutral pressure plane, right? And being able to see what affects duct leakage and my exhaust system has on that. And if I'm climbing with my neutral pressure plane, now I know that I'll give my attention to the top part of a house, especially on 2-story. If I got a crawl space and my pressure plane drops, I'm going to put my attention down below. Not to discount either, but that's where my attention can go to get the biggest impact for what I'm trying to accomplish. But infiltration is huge, and if we're going to be doing good load calculations, we need to put that number in there and not just default. We got a bunch of guys out there just using default numbers all over.
Guessing average.
And close enough is not really good for where we're at in our industry with today's technology. And the last thing, to your point, Sam, would be pollutant identification and source control. In my class, I'm constantly source control. So if we can identify a pollutant, whatever that may be, TVOCs, organic, synthetic, particulates, we can identify that, then we can have a better idea on where they're coming from. Are they outside getting in? Is it something we brought into the space? Is it something we built the space with? But now we've got a fighting chance of identifying the source, and let's go after that first. So those are like 6 key principles. And then after that, we can go diving into some different things. We can spend a lot of time on psychometrics, and we can spend a lot of time on identifying molds and spores and bacteria and things as well, which is equally as important. But keep it dry, keep it clean, keep it ventilated, keep it thermally comfort, keep our pressures in place, keep it dry.
All those components have to work together, right? It's a system.
Do. The whole house is a system.
And you mentioned earlier too about, sometimes if you have to add ventilation or something, it's an energy penalty. But a lot of times if you're addressing that source control too, that involves some type of improvement to the building enclosure. So you're tightening things up. So a lot of times you make up for it, if not more so. if you have to add an energy penalty someplace else.
Sure.
So sometimes it can work itself out.
I always say too, it's not just indoor air quality or indoor environmental. We are changing environments. We are changing the dynamics of a home by everything that we do, cause and effect. And then by the very means we try to solve one problem, we very well could be creating another problem.
For sure.
And so knowing the cause and effect and being able to put numbers, we have to be data driven. I talk about that all the time. I did a talk on turning data into dollars and how having a set of data points, having good efficacy on that data, right? Accurate data, and then being able to analyze and discern that data to build a pathway forward is like so crucial, and not just in indoor air quality and building science, and then HVAC as well.
Yeah. Do you have any do you still teach classes and stuff, trainings? Like,
yes.
Do you have any coming up or anything like that?
And thanks for asking that. So I've had the wonderful privilege of teaching indoor air quality for Daikin and Amana Goodman for about 6 years. When they approached me, they said, "Hey, look, we want to create a curriculum for the industry." I say, "Hey, I am absolutely your guy, but I will not stand in front of a group of people or a classroom and sell products because that's what everybody else does. It has to be the nuts and bolts in science." So my class is built on building science, building forensics, and indoor air quality from a mechanical point of view, built it for this industry. And then we go broader as well. And so right now I have some private coming up. We are coming into training season. And so I have some potential classes coming up through different distributors. Not only do we do Daikin and Amana Goodman, but we got a lot of independents like Williams and Johnstone and Stevens Supply are all like independents now of the Daikin products. And so, but I just finished my 5-year do not compete. So I still teach for Daikin, but now I'm doing them privately. The cool thing is I wrote the curriculum, so the intellectual properties are mine, and then
nice,
cool.
Everything is mine, and so we just pull out the branding, and now I'm doing it private. I take it right to contractors. I just did one in South Carolina. They have 45 guys. I did half their class, half their company for 2 days, and the other. He's funny, and you'll like this. He called me. He's like, "John, we got this old house. The guy's got some problems." And
that's perfect.
and he's like, he took his guys there, and they're doing some blower door testing. And he tells his guys to go take a receptacle off the wall. They looked at him like he's crazy, and so he said, "Tell me what you see." So they pulled it on me, looked in, and he goes, "Oh, they're spider webs." And he's like, no, those are cobwebs, and they could feel the air coming out of a receptacle. And we've done testing. I told you in California, we geeked out on a bunch of stuff. On average, if the conditions are right, each wall plate or receptacle can leak 3 to 5 CFM throughout the house. And so if you think about it, it's such a minute amount for one. That's a lot. So we had this.
Plus everywhere else on the wall it's coming out of too. A lot of the times it's coming out of the bottom of the drywall, underneath baseboards and things too. So
yes.
And again, it's about finding that source. Like, why is it coming out there? A lot of times it's top plates, or maybe there's a chase nearby. So.
What's the driving force? Yep.
Yeah.
And then
that's awesome.
As you know, we got stack, wind, and mechanical, and usually mechanical is the biggest impact, but not to discount the other two. But
well, especially where we are. You said you were in South Carolina. I'm, just above the border here in Wilmington, North Carolina, and we love putting all of our ductwork and mechanical systems outside of the envelope in a vented attic or in a vented crawl space. And so then, we get a lot of that mechanical push and pull, depending on where the majority of the duct leakage is.
Yeah.
So it's very common around here.
Yeah.
Cool. So you mentioned earlier, that some folks will throw a gadget in a duct system and hope for the best.
You weren't talking about UV lights, were you?
So that's leading up to my next question is, we've talked a lot about like the right things to focus on, all these principles to focus on to get a house to work the way it should. But what's the industry doing wrong?
Well, the lack of knowledge, for one, and with lack of knowledge comes not understanding the science. And so, Ben, you mentioned UV lights. Out of all the things out there, I'm okay with UV lights. they've been around for a long, long time. They're tried, true, and tested. If they're installed right. Like I get asked, hey, what's the best equipment? Well, the properly designed, installed, commissioned, and maintained. Well, the same thing. If you install a UV technology the correct way, it can work. And it needs to be able to treat a surface. I see them in the weirdest place. I've seen UV lights in an outdoor condensing unit. I kid you not. I've seen them in an air cavity.
Just put them everywhere.
They're meant to treat a surface. And anybody said that will treat the air, I'm sorry, the science doesn't match up. So UV technology works on a three-legged stool principle. It would be the intensity of the UV spectrum. So you have UV, UVC, UVA, far UV. We've got LED UVs, but that intensity at 27 nanometers has to be proper. Then the distance that UV spectrum is from the surface we're trying to clean, which would be an HVAC coil, and then dwell time, right? The amount of time that light can be on that surface. So if we're looking at an A coil, and I see him up here, and I just got a call just yesterday, he's asking me about it. He's like, yeah, we typically put them, I'm like, great, on top of the A coil, that little piece of metal right there, that is the cleanest piece of metal in that whole which doesn't really have any air going across it. So if you really want to treat an A coil properly, I call it triple safe UV sanitation. You have to have one in the center on the inside and then one on each side of the outside. Because what's happening? We're removing moisture. That coil gets wet. Positive pressure from the inside, negative outside, right? Pressure difference in an opening. Not only is air going, but the water is migrating as well. And if we have any kind of microbial, it's migrating with the water as well. So a lot of that stuff ends up on the outside. Another part for microbial growth, we need oxygen. We're always going to have oxygen. We need moisture. So during operating conditions in the summertime, we're going to have moisture, and we need food. So we can get rid of the food if we have a tight duct system and good tight filtration. Now we don't have food on the coil. Now we can limit the possibility of microbial growth, right? And so I am okay with UV technology if it's installed properly. Won't do anything in an airstream. 492 feet per minute. Whoop, that bacteria just went by. It's probably saying, let's do this again. That was nice. So then if we move forward, and the big one has always been photocatalytic oxidation, PCO technology. So basically that uses a UV spectrum that interacts with a substrate. That substrate is titanium dioxide. There is a reaction that creates a hydroxyl radical. That hydroxyl radical is exactly what it's radical, and that will attach to a bacteria, spore, or virus, or a microbial, and as it breaks down that with it. Let me back up. A lot of misconception about UV. Oh, it kills. Well, no, it doesn't kill anything. It breaks those things down on a molecular level so they can't reproduce. Therefore, they die off. We're not actually killing them. Now, if you put it in a petri dish, and it has nowhere to go, it might kill it. So that is how PCO works. And so we need to talk about efficacy. So one, the hydroxyl radical will attach. So you have that PCO element. Let's see if I can get that in the picture, right? And it's not that big, and it goes into a duct system. And so you have whatever that duct system may be. Let's say it's a 22 by 29, right? And you stick that in the airflow. If you look at, and so that airflow is at 392 feet per minute, whatever volume, depending on the size of the equipment, needs to go through that element to get exposed to those hydroxyl radicals that are happening in that device. So you're actually only exposing about 8 to 12% of total volume goes through that system. And then, so that air, that let's just say 12%, let's be very generous, is treated. And let's say there was some success. Well, it goes back into the air, into the space, remixes with the environment, then hopefully goes back through. It becomes the law of diminishing returns. So what's in the space? Because we haven't talked about any of that. And as that 12% of the air gets remixed, is it just repolluted?
Dilute it back out, yeah.
Yeah. And so where's the efficacy there? And then we got to talk about byproducts. Our goal is to identify a pollutant and get to the source and remove it from the air. If a said technology depends on putting stuff in the air, I think we're going backwards because there are byproducts that come off of that. Formaldehyde is one. That's a VOC. Nitrous acid is created as well, and it does create a pretty good amount of carbon dioxide. If we have a space that has high carbon dioxide, I think the last thing we want to do is introduce more. Formaldehyde's a known TVOC. Oh, well, John, they're trace amounts. Well, I'm here to tell you that low-level, long-term exposure to any pollutant is bad news. Just like carbon monoxide. Low-level, long-term exposure is devastating. If you have an event and you can identify it quick, I mean, some people die, I understand. But low-level, hey, you know what? I've got myself a big box detector. Goes off at 70 ppm, but I'm hanging out at 35 ppm for years. Devastating. Low-level, long-term exposure to any pollutant is not a good thing. So that's some of the things we got to take into effect. And then the other big one would be ionization, whether it's bipolar, needlepoint, they call it many things. So the concept behind that is we're going to release negative ions into the space. So negative and positive ions happen naturally in nature all the time, but we're going to force the issue and create negative ions. So negative ions go in the air, they attach to a particle, and opposites attract. So the positively charged particles, will come together and clump, And
then they fall down.
Well, they get large enough to get trapped in the filter, or they get heavy enough that they fall down. So one, we don't know what the particles are because we haven't speciated. And so if they're all clumping together, and particles, depending on what they are and what size they are bad in and of themselves. But we've just created a super particle. But we brought them all together, and then they fall to the ground. Anybody who has toddlers, infants, small children, pets, where do they play? They play on the ground. So now
they sure do.
We're subjecting our children to charged particles, a super particle that when inhaled, its charge can stick to the lungs. And early childhood asthma is on the rise. We got ADHD and some other things that have been on the rise. I don't know if there's a direct correlation because not everybody's using ionization, but just breathing those particles and indoor pollutants have been attributed to some of those rises. And so I think that's probably the last thing we want to do for that application. And then the other part is they get big enough and heavy enough that they will get trapped in the filter. There's been peer studies that looked hard at this and said that the enhanced filtration because of bipolar ionization in a residential application is negligible. It couldn't be measured, the benefit. So if I've got a particle that needs to get to a low wall return, what's in the way? Particle, low wall return. Well, we are. So now we're breathing those particles, and it's up to us as the occupants to hopefully clean them up, and hopefully it's a HEPA vac because otherwise they'll just get re-aerosolized and the whole process just starts all over. So I've looked at the science. I've called all these guys and say, hey, you know what? I'm just a tin knocker, but kind of a geek on numbers. And what testing methodology can I use to qualify, quantify, and verify that your product is doing what you say it's going to do in my customer's home? Oh, John. Oh, my goodness. The type and the expense of the equipment you would need. That's by design.
Too expensive. Yeah.
Because you read the marketing material. Oh, we do 99%. Well, 99% of what? Oh, just 99%. But what they don't tell you is a very controlled.
We do a lot.
A very controlled, sterile environment in a laboratory in a petri dish, and they bombard that petri dish with whichever technology they're using, and then they look and it's like, hey, we got 99%, and they take that, they put it in the marketing. Are they lying? No, not really.
Yeah,
but
sort
they're
of.
not being forthcoming.
But not in a real world scenario.
Yes.
Yeah.
So,
but I guess the challenge is that it's easy to install. It's a device you can show off, and fits in a box and can be marketed as a silver bullet. And that's just kind of what I've been seeing, especially since COVID happened.
Yes,
And
that was a big push. It's a revenue generator.
It's hard to get around.
Yeah. And you know, I do these trainings all over the place, and I'll go in and teach a company. And I had one I was teaching in Canada, and there was a guy there, and he had almost like a Super Bowl ring, and he was from one of the big franchise companies, and I won't say who they are, but he was a big dude in that. And when I got to this topic and started talking, he was squirming in his chair, and he was very uncomfortable, and he was mad because I was telling the truth. And and so how do you tell a company that's making an additional $70,000-$80,000 a year on selling smoke and mirrors, you know, as a pseudo IAQ, and they're betting the rent on that?
Yeah, they're doing a disservice to people. Yeah,
and the technicians are getting $200 every time they sell one as a spiff. I mean, it's almost like a multi-level marketing deal with those things.
Yeah. But I mean, if your goal is to do the right thing, actually fix the problem at the source, then stuff like that's just not going to fit in.
Yeah. We need to be data driven, and we need to be solutions based. Let's sell solutions. And that's what I told, you know, when they approached me to develop this class. It's like, you know what, I don't want to sell products. Let's sell solutions.
Yeah, and I think the fact what you said, let's take stuff out of the air and not put stuff into it.
Yeah, that's
a really good takeaway.
Yeah,
that most people can understand. So,
and this, you know, to truly do the research and understand any kind of technology that you're about to put in someone's home, that you understand how it really operates and whether it's really going to be beneficial or not. Or
and you know what, for maybe a healthy young male and maybe a female as well without young children, maybe it's not going to be an impact. But in the long term, we don't have enough data, especially on ionization. We still don't have enough data behind it to really look at the adverse effects of being exposed to that. But I'd rather just cut to the chase. Let's not put that stuff in.
Yeah.
Nice.
Well, cool. Well, John, this has been awesome, man.
Yeah, that's probably one of the more informative episodes we have, really, for your knowledge base. That's great.
Wow, we didn't even get
what to do and what not to do. That's what everybody needs to hear.
Yeah,
because there's just a lot of bad advice going around, and thanks for helping us kind of.
I've got so much other stuff too. If you guys wanted to do this again, you know, because I've been doing HVAC and building science for so long, I had the pleasure, because I do some work with the new flat rate, which is a menu pricing system. And Rodney and myself developed the very first and only IAQ and building science menu pricing module within the new flat rate. I've taken all of what I gave my testing away forever. Because I was excited. Right. It's like, whoa, I got all this new knowledge. Let's go do it, right?
I want to share it, yeah.
And then always like, I'll make up for it on the back end. Now, I did have a high closing rate, but not all contractors are lucky as I was in my marketplace and being so niche. But contractors give it away. And so we developed this menu pricing that gets us paid every step of the way from the discovery, right? From testing into creating a scope of work, and then also selling that scope of work, selling whatever that prescription may be. And we're using it all over the United States. We baited it, and guys are having great success with it. So that's
awesome.
That's great. Because I mean, like, if you go to the doctor and they run labs or do diagnostics on you, you're not getting that for free.
Nope.
So I mean, it's, you know, our houses are kind of
you can't even walk in with a door for free.
and just plus the knowledge that we have behind it of like what we actually, you know, the knowledge that we have in building science that we apply to those measurements that we take in the field. I mean, it's, you know, for your basic run of the mill contractor is just not going to have that. Well, yeah, John, we'll definitely have to do this again.
Yeah, definitely. Yeah.
And hopefully next time you're further down the road on your next product that you're working on. So be excited.
Yeah, as we talk about that. Yeah, exactly.
Yeah, we can. I'd tell you now, but I'd have to kill you.